topic is basic introduction of MEMS. So, in this lecture, we will discuss in detail the basics of microelectromechanical system and its component, fabrication process and application in detail. MEMS is a microelectromechanical system. It is a technique which is combine electrical and mechanical components togetherly on a chip, and it is used to produce a system of miniaturized dimension. So a very small device or a small component chip is designed using MEMS technology. MEMS is a integration of number of micro components on a single chip. This system allows the microsystem and both senses and control the environment. The components are integrated on a single chip using microfabrication technology. So here we can see on our screen that using electrical and mechanical system jointly produce a MEMS system. The topic is basic introduction of MEMS. So, in this lecture, we will discuss in detail the basics of microelectromechanical system and its component, fabrication process and application in detail. What are MEMS? MEMS are microelectromechanical system. It is a technique which consists microelectronic elements, actuators, sensors and mechanical structure which built on substrate. Usually silicon used as a substrate material. They are developed using microfabrication techniques like deposition, patterning and etching. The most common form of production of MEMS are bulk micromachining, surface micromachining and fabrication. So the benefit of this small scale integration brings technology to a vast number of variety and devices. Basic components of MEMS are microelectronics, microsensors, microactuators and microstructure, which can be seen in the picture. The microelectronic use as the brain that receive the process and make decision, and it also use as the data comes from microsensors. The second is microsensors. The microsensors consist uh, data which is gathered from the environment, and it passes the data to microelectronics for further processing, and it also can monitor the mechanical, thermal, biological and chemical readings. Next is micro actuators, which act as a trigger to activate the external devices. The microelectronics will tell actuator to do the activity. And the last one is microstructure. The small structure built on surface of chip is done by the microstructure, and it is also used to build the right into silicon of MEMS. So these are the components of MEMS device. This slide shows the working of MEMS technology. The overview of a MEMS system is shown below. The MEMS system is developed by combination of conventional complementary metal oxide semiconductor, which is commonly called as CMOS device. It has the microsystem, which consists integrable sensors, actuators and the components. So it is an inbuilt system which consists of system techniques, micro techniques and the materials and its effects. This type of techniques used in process engineering, medical technology, automotive technology and robotics. So we can see the MEMS chip, which consists of all devices on a common chip. In this MEMS, the films is made using a wafer which is called CMOS. For the fabrication process, the material which have used are silicon, polymers, metals and ceramics. And the basic process is including deposition, patterning and etching. So the basic fabrication is same as we all know. The deposition is including depositing a material on the surface on a substrate, and the patterning includes lithography process, and after the etching of unwanted material we can get our desired pattern. So now we'll discuss in detail. First is deposition. The deposition will happen because of the chemical reaction or some physical reaction. Basically, the deposition is a process in which a thin film of material have deposited on a wafer, and during the fabrication of microsystem several layers of different material are deposited. Each layer and each material serves a distinct function. So in this unit you will know the overview of the deposition process and the various types of deposition used for microsystem fabrication. Next is patterning. The pattern is transferred to a photosensitive material by selective exposure to a radiation source like light. If the resist is placed in a developer solution after selective exposure to a light source, so it will etch away. So the photolithography process is used in this, which defines the transfer a pattern on thin film layer on the wafer. In this process, a light source is used to transfer the image from a pattern mask to a photosensitive layer on a substrate or another thin film. So this pattern is later transformed into the substrate or the thin film using different process which are called etching process. Fabrication process includes deposition. Thin film deposition is done by physical or chemical deposition. So to deposit a material on a substrate is in range of few nanometer to 100 micrometers. It has two methods. First is physical deposition and second one is chemical deposition. The material placed on substrate using by physical vapor deposition or the physical deposition has two methods. First is evaporation and second one is sputtering. Similarly, for chemical deposition there are also two methods. First is chemical vapor deposition and second one is atomic layer deposition. Substrate may be used as silicon, glass or quartz substrate, or the thin film will be made by polysilicon, silicon dioxide, silicon nitride, metals and many more. Patterning is used to transfer a pattern into material after depositing in order to prepare for etching. So technique which includes some type of lithography is common method is there. Etching includes wet etching or dry etching. Wet etching is a dipping substrate into chemical solution that selectively remove material, and dry etching dissolves the substrate with plasma or gas variations. MEMS micro machining technologies including three type of techniques. First is bulk micro machining, second one is surface micro machining, and the third one is high aspect ratio silicon micro machining. The bulk micro machining technique is the oldest technique which involves selective removal of substrate to produce the mechanical component. So it is accomplished by physical or chemical process, and the two type of isotropic or anisotropic etching method is used for this purpose. Isotropic wet etching is that in which etch rate not depends on crystallographic orientation of substrate, and etching moves at equal rates in all directions. In anisotropic wet etching, etch rate is dependent on crystal orientation of substrate. So here we can see this in picture. Similarly, the surface micromachining technique, which also can be seen in picture, the process starts with deposition of thin film that act as a temporary mechanical layer which called as sacrificial layer. The device layer are constructed on top. Deposition and patterning of structural layer is done, and the removal of temporary layer is allow movement of structural layer. So the benefit are the variety of structure may be possible, sacrificial layer and etchant combination use single sided wafer processing, and the disadvantages are mechanical properties of the thin films are usually unknown. So we can see surface micromachining in the figure B. In this, desired microstructure can be obtained. Micromachining technique involves selective removal of substrate material to realize miniaturized mechanical component. So the etch grooved using three type of etchants. First is anisotropic etchants, second is isotropic, and third one is reactive ion etching. So the widely used bulk micromachining technique in MEMS is chemical wet etching, which involves the immersion of a substrate into solution of reactive chemical that will etch exposed region of the substrate at very high rates. In surface micromachining, the MEMS sensors are formed on top of the wafer using deposited thin film material. So here we can see in picture, in A, the space layer deposition have been done. A specific layer have been deposited on silicon substrate. In B, the pattern of spacer layer has been formed using etching and patterning. In figure C, we can see that the deposition of the microstructure layer have been done using a polysilicon layer. In image D, we can see here the patterning of desired structure has been done using same process like masking, etching. In figure E, the stripping of spacer layer resolves to find the final structure. So this is the surface micromachining technique. Wafer bonding is a technique which involves to join two or more wafer together to create a wafer stack. The three type of wafer bonding are there. First is direct bonding, second one is anodic bonding, and the third one is intermediate layer bonding. All require substrate that are flat, smooth and clean in order to be efficient and successful. So here we can see this in the cross section of silicon wafer demonstrating in this picture. And this high aspect ratio fabrication is a deep reactive ion etching technique is used in this, which enables very high aspect ratio etches to be performed in silicon substrate. The side walls of etches holes are nearly vertical, and the depth of etch can be hundreds or even thousands of microns into silicon substrate. Thank you so much for listening patiently.